if alpha is a small number, much less than 1, then this term right here becomes insignificant. This term becomes insignificant. We're not really going to get rid of that one, but it's a small deviation off of 1. And so if alpha is much less than 1, then 1 plus alpha to the nth power would just be 1 plus n alpha. The same holds true whether the exponent's positive or negative. We still do the expansion. And so 1 minus s over 2r to the negative 2. So if I treated this, sort of brought it up top, make it the negative exponent, this becomes 1 minus negative 2 times s over 2r, which, again, approximately, and that equals 1 plus s over r. We are making the assumption here that r, the distance big Q is away from this dipole, is significant. In other words, that the distance between the two little charges is small compared to the distance to the big charge. And so this becomes k little q big Q over r squared times 1 plus s over r minus 1 minus s over r. The ones will cancel out. I'm left with k little q big Q over r squared times 2s over r. Which is k. Did I lose the minus sign at all? Let's see. That's right, ultimate is from delta. Okay, so we're good. K big, I want to do that in a different order. So we got 2k big Q little q s over r cubed. It is a positive value, assuming that the q's, that little q and big Q are both positive, and so that means that the force is in the positive direction, or to the right, the way I've drawn it. This right here. Because remember that the dipole has some charge little q and a negative q here with some distance s between them that's fixed. So for a particular dipole, q and s really are, those are two key values. And we have them showing up down here. And so of course physicists looked at that and they said, hey, let's come up with a new name for it. So if you think about a vector going from the negative to the positive charge, and then recycle a letter that you've used already, because that's the same symbol we use for momentum, but it's not momentum here, is equal to q times s in the direction from negative to positive. And this is known as the electric dipole moment. Make sure I didn't get that backwards. Yeah, that's right. And so we can express the force here. 2k big Q over r cubed times the electric dipole moment. Main reason I'm going over this is, one, dipoles do show up realistically for, again, as I said, polarized molecules is the most common place that I see it. But especially if you get into electrical engineering, you will face this again. And so I want you to at least have seen this so that later on when you're at whatever school you're at, you'll have some, at least go, oh, wait a second, I know I've done that before. Personally, when I'm writing tests, I'd be more apt to not say, hey, the electric dipole moment is, I'd be more apt to say, hey, I got two charges of opposite values that are situated a certain distance apart.
If the dipole's flipped, would we use the opposite of the dipole moment or no?
No, well, if Q and negative Q flipped here, then then the direction of the dipole moment is just in the other way.
Okay.
So it would be in the negative direction, which would put the force would be attractive to this.
Yeah, okay.
Right, other questions up to here? So I'm about to ask a philosophical question. All right. I'm going to ask the question, then we'll take a small break while you ponder the answer. If you know the answer, just sort of hold on to it for now. I have a universe. I've created it. Into this universe, I put a proton. It's sitting there, fat, dumb, and happy, just sitting there. There's nothing else to exert a force on it. It cannot exert a force on itself. It'd be an internal force, so it wouldn't cause anything. It's just sitting there. Into this universe, I put another proton. What's going to happen?
It'll repel.
There we go. So, here's the philosophical question. How does the second proton know the first proton is there? Or how does the first proton know the second proton is there? If they repel, there has to be something that tells them, oh, there's something else there. Run away. Or if I threw an electron in there, ooh, there's something else there. Let me see what it is. And with that, let's take a 5-minute break, stretch your legs. I'll check on the course entry assignment, and then we'll reconvene and talk about the stuff that physicists made up to make this work. All right. First off, before we talk about how one proton knows the other proton exists, Chapter 23 I'm officially done with, so let's talk about master set and quiz. This is quiz, however you want to word it. I'm thinking, I don't want to push it off too long. Tuesday seems too soon, but it wouldn't have had, if you had bothered showing up on Tuesday. And for all the video fans out there, YouTube fans, that there was snow on Tuesday, just so you know. And this is the South. All right, I'll just leave it up to you. The quiz next Tuesday, get it done with, or the quiz almost the Tuesday after.
Would we be reviewing more concepts that would be on the quiz this Tuesday?
No, I mean, the only thing that would be left is that when they come in and say, are there any questions, if you have questions about some of the homework problems. I mean, the solutions are posted, so you should, I think I have the solutions posted under supplemental material if I set this class up like I did the other classes.
Is there, can we see the homework problems on there, or is it only in the textbook?
See the homework? Oh, the textbook homework problems?
These.
Yeah, those. Oh, and there was also a question about what the flash quiz looks like.
Something start with an integral.
Yeah, it starts with, everything
So give you an example, this is what the flash quiz kind of looks like. It's just, if you've gone through the flash material, the flash knowledge, it's just regurgitation, it's translating what I'm asking to which card it is. So this would be done first before the homework questions.
Okay.
So. All right, so next Tuesday or a week after for the homework. I'm not talking master set, we'll deal with separately. So I'm gonna take from the assigned problems, there's 7 that are eligible to be on the quiz. I will take 2 of them, change the numbers. That's the homework quiz.
Oh, so the homework quiz is based off the homework, or
Yeah, off the textbook problems.
the ones in the book, not these? Well, these are in the book, but they're not based off of these, they're based off the one that's,
The textbook, the problems in the textbook.
okay.
And when you flashed that before, was that the?
This is the homework, but I don't.
Yeah, so those are the 7 problems. I think it's 7. 1, 2, 3, 4, 5, 6. Those are 7 problems. I can take 2 of those problems right there. 2 of the problems, change the numbers, and that'll be the quiz. So if you knew how to do those, and you have solutions there, chance to ask questions. If you know how to do those, you should just sail right through that.
Do we get partial credit if we?
I have survived many courses on partial credit. I believe in it.
Okay.
Great deal.
This is the master, I guess.
That's the master set, yeah.
We gotta turn this in.
Yeah, we'll talk about that in just a second.
Okay.
Because when that's due might be affected by when the other thing is. So,
I think Tuesday, like a week from, a week from 2 days ago.
okay, so in 5 days.
Yeah.
All right, so homework quiz, Tuesday,
25th.
okay, I'm being told the 25th.
And that would be the flash quiz also?
Yes. Flash quiz is a timed 10 minutes. The one that I showed people around was the flash for chapter 24. So chapter 23 is what you have coming up. If you got a photographic memory, then, well, it doesn't give you much of an advantage since you know what all the questions should be anyway.
And those 2 problems, we have the rest of the class to do.
Say it again?
The 2 problems, we have the rest of the class to do.
I hope it doesn't take you 2.5 hours to do it.
That's not lecture day though, so we gotta.
All right, so let's talk about for those people who aren't prepared to do it quickly. Because I did have a student a couple years ago that I don't think he ever opened his book. I don't even know if he had the book. So he'd come in, he would take like an hour to work that quiz. At some point, I'd say, hey, why don't you finish it up in the hallway? And so he'd go in the hallway and I'd start doing class. So that's generally the way I handle the student who needs that extra time.
That's rough.
I have, every semester, I go through this, should I just put a time limit on it? Just because you should have worked the problems already before you walk in. It shouldn't be that struggle. At 252 students and 251 students, more than any other groups I have, will stare at a problem for a half hour trying to figure out, hoping for that flash of insight, which sometimes comes, which encourages them to do it again next time. I'd like to think you come in prepared, the homework quiz is done in 10 minutes, everybody's handed it in because all of you know that material so well. You know those problems so well. That's my dream. And this is the group that's gonna do it. So, if the class as in general is taking way too much time, then I might just say, hey, you know what, that's plenty. Let's just bring it in. If it's an individual, I'll ask you to step in the hallway. I hope it doesn't come to that, but that's the way I've dealt with it in the past.
Okay, I was just curious.
All right. So next Tuesday, this coming Tuesday, the next Tuesday we come across, 5 days, homework quiz, flash quiz, homework quiz. All right, master set. That is the other thing that Devon printed out. It is 8 problems, and 2 of them have multiple parts. So, and by the way, that first one, that first question up there, feel free to use trig substitution if you want, or use the formula.
What's the 2/3?
Pardon?
Oh, yeah, 3/2. Okay, yeah.
And factor the 2 out. Yeah, that was the test question that one student actually did trig substitution, did the whole thing correctly. As long as you got loads of time, no problem. But that was back when my test, at 4.5 hours, I said, that's it, we're done. I gotta go home. Anyway, master set. Do next Thursday, does that seem realistic?
Do we bring it in or do we gotta like upload it?
That one, bring in.
Bring it, okay.
I'm trying to remember if I set it up for it to be uploaded. But I was picturing it being brought in. I guess if I have it set up to be uploaded, then I'll take either. All right. Master set next Thursday. I didn't hear an objection to it, so I'm figuring that's good enough.
I'm trying to breathe right now.
Was that?
I'm trying to breathe right now.
Oh, okay.
I love how you make the master set sound so simple with 8 questions.
And then that would be the 27th, right?
Yeah. Sure. Master set are old test problems. So, now, whether the problem has a solution already posted under old test, I don't know, but I do have more solutions for 252 than any other course I teach. So, long, drawn out solutions, went through, used the equation editor, the whole bit. And occasionally there are mistakes that students point out. And I think, all right, somebody actually looked at this. I didn't spend 6 hours in vain. Which I sometimes think as I see some videos and I'm going, only 2 people have watched this out of the past 5 years, huh?
I was looking at some of those videos that we were supposed to watch for the syllabus, and it's like maybe 50 views on the YouTube video, and I'm like, okay.
I do have one video that's had 1,300 views.
Yeah.
Yeah, wow. The last I think it's primarily overseas. Because, or people are watching it in the middle of the night. Very odd. All right. I think we're now to this. So, how does one proton know the other proton is there in order to run away?
Magnetic field?
No, not a magnetic field.
Has a sense.
The charges have to be moving relative to each other for the other one to experience a magnetic field. And when they first start out, they're just sitting there.
Like a sense of each other being there.
Yeah, what's causing this sense?
It's given to them.
Missed it?
It's given to them. I mean, if they just show up, it's given to them.
You got 2 of the same charges in the same universe, so I guess they will repel.
Yeah, but in order to repel, it has to know, I mean, how does this know it's a proton and not an electron? It's got the ISR on and it's sort of shifting around till it.
It's gonna naturally repair because they're the same charges. Well, I see what you're saying. I'm trying to.
I will say that it's sort of given, it has some sense. That's almost what the physicists came up with, that it it's not that it has the sense. Yeah, I'm not quite sure how to word it without giving it away. Devon, you were working through it, and I was wondering if what you're gonna come up with. Or,
I'm stumped.
it's not okay. Sorry, did not mean to put you on the spot like that.
Oh, you're good, you're good.
They figured that whatever it's sensing, whatever this second proton is sensing, that had to have been there before the proton showed up. So in that sense, you were right. It's not like it's given the sense of everything around it. It's that there's something around it. There's something in the space that this proton is producing. I will sometimes refer to it as electric pheromones, but I'm the only one who refers to it as that, perhaps some former student, but I doubt it. So if you talk about electric pheromones to some physicists, they're gonna look at you strangely, wondering what you're talking about.
So it's like an odor of some sort.
So it figures that this proton's giving off something. You know it's not an odor because the lines aren't curved. That's the smell line. All right. And it can only depend upon one charge. Whatever's there to begin with, it can only depend upon one charge. Well, what we do know is Coulomb's law, which depends upon two charges, so let's just write that one down. So the force on one from two is equal to Coulomb's constant, Q1, Q2 over R squared, R2 half. All right. Since this is the force on charge one from charge two, the thinking is, well, what is charge two doing that our charge one has? And so what they decided to do is, hey, you know what, we got this force, we don't want to charge one because we're saying charge two is giving off something, so let's just divide through by charge one. And so charge one is now taken out of the equation, so we have this electrostatic constant times Q2 over R squared R2 hat is equal to what the force would have been divided by the charge that would have been there. And they called this the electric field. I think this is early 1800s when they come up with this. For 60 years or so,